Okay, so today we're going to start talking about plate boundaries. So you have to imagine a single plate moving in one direction on the Earth's surface, where one edge of the plate is a divergent boundary, meaning that the plates are going to move away from things, and on the other side would be a convergent boundary, where they're bumping into each other. So divergent, plates move away from each other. Convergent, they're coming together. We also have transform plate boundaries, which are where they slide past one another. So here you can see that they're sliding past one another. So these are our three types that we're going to be responsible for. Again, they're divergent, plates moving away, convergent, plates coming together, and transform, they're sliding past each other. So divergent boundaries are the type of plate boundaries that we'll find in the ocean as mid-ocean ridges, like we talked about with seafloor spreading last class. A divergent boundary is where the line between two plates are moving apart or away from each other. And again, this is going to be caused by convection cells happening in the mantle. So remember our example of the lava lamp. When you turn a lava lamp on, the wax at the bottom is all at the bottom. As the wax heats up, it becomes less dense. It's going to rise to the top. As it rises from the top, it's away from the heat source. It's going to start to cool, become more dense, and sink back down. Same thing as what's going on at our mantle, in our mantle at mid-ocean ridges. Here are some pictures of divergent plate boundaries. If a plate boundary is in the ocean and it's a divergent plate boundary, we are going to get mid-ocean ridges occurring, which we see over here. And if they occur on land, we'll get rift valleys to form. So divergent boundaries that are found on continents are rift valleys, and we have that happening in Eastern Africa at the East African Rift Valley. And when a rift valley forms on land, it will eventually split the landmass apart. So millions of years from now, these are going to be separated. Convergent boundaries are the plates are coming together. They're colliding into one another, and one is going to subduct underneath. So one's going to be pushed back down into the mantle. This forms a valley on the ocean floor, and we call those trenches. So here we have an oceanic plate that is older and more dense, and it's going to be subducted or pushed back down underneath the younger oceanic plate. As it gets pushed back down, it's going towards the heat source, so parts of it may melt, and this is how we might get some island arcs to form. So what happens if an oceanic plate collides and a continental plate collides? Which one would subduct? So we're always going to have one subducting, and the oceanic plate will always subduct underneath the continental plate, and that is because the continental plate is too buoyant or it's less dense than the oceanic plate, so the oceanic plate is going to subduct down and go back down towards the mantle during that. So here we have the collision of two plates, the Nazca and the South American plate, and this is how we get the Andes Mountains forming in Peru. So what happens if an oceanic plate with a continent on it subducts underneath the continental plate? The continents won't be sucked into the trench because they're have too light of a density. So we're going to have more mountains forming. So again, this is a convergent plate boundary where we have two continental plates colliding, and this is how we get our mountain ranges forming. The two plates are going to collide, they're going to be pushed up, and mountain ranges are going to form. So this is what we have happening in India and the Eurasian plate. India is being pushed into the Eurasia plate, and that's how we get the Himalaya mountains forming. So transform, remember they're sliding past each other. A good clue for this is we'll often see offsetting. So this is an example of the offsetting that we see. We'll see a zigzag feature being formed. The evidence of rock moving against rock is evidence of the plate boundary, and we'll see that with the slickened sides, which are smooth, polished surfaces. You might want to pause the video and figure out plate A, B, and C. So hopefully you found that plate A. The plates are pulling apart, showing by evidence of the way the arrows are moving. So if they're moving apart, we know that it's a divergent plate boundary. It's happening in the ocean, so we know it's going to be a mid-ocean ridge, and that's the mid-Atlantic ridge. So remember, at mid-ocean ridges, we have new ocean crust being created. At plate B, they're colliding together, so it's a convergent plate boundary. The Indian-Australian plate is being subducted underneath the Eurasian, forming the Himalayan mountains, which are going to continue to grow taller and taller as those plates are colliding into one another. Again, at plate C, they are colliding. So it's a convergent plate boundary. The Nazca plate is being subducted or pushed back down into the mantle underneath the South American plate. This is forming the Peru-Chile Trench. So remember, trenches are where the plates are being destroyed. Mid-ocean ridges are where new crust is being created. So if we're making it somewhere, we have to be breaking it somewhere. So new crust is being made at the mid-ocean ridges, and old crust is being destroyed at the trenches. This explains why the Earth is getting bigger and bigger and bigger in circumference as this new ocean crust is being created at the mid-ocean ridges, because it's being destroyed at trenches as well. So here we have the Earth's largest lithospheric plates. We'll talk more about them later on. And then the geology connection, where to go for volcanoes. There are many volcanoes in the mainland of the United States. In the recorded history of the Earth, more than 500 volcanoes have erupted. And our next note sections will be on volcanoes and earthquakes. We'll dive deeper into how these relate back to plate tectonics.